Hello and welcome to Space, and this month we're taking a look at the risks posed by asteroids. With Asteroid Day on the 30th of June, there's growing awareness of the threat these space rocks represent. We're here at ESA with the asteroid hunting team, but first we're off to Vienna and a little history lesson. 66 million years ago, the dinosaurs ruled the Earth. Now they're nothing but models and fossils found in places like the Natural History Museum in Vienna. What killed them off was an asteroid, a lump of rock and metal left over from the formation of the solar system.
66 million years ago, an asteroid was on collision course with the Earth. The asteroid was just 10 kilometers, but the resulting crater 200 kilometers. So that tells us about the enormous energy that is involved in such a case. And that energy is like a gigantic explosion. Earthquakes happen, all kinds of nasty things. So the climate changed immediately. And what that meant is that a lot of the animals and plants at that time almost immediately became extinct. About 2/3 of all living species on our planet became extinct.
Nothing comparable has happened since. However, as this footage from 2013 shows, the risk is low but ever present. An asteroid just 20 meters across exploded above the Russian city of Chelyabinsk, injuring 1,500 people. Studying it can teach us a lot.
Here's a piece of the meteorite from Chelyabinsk, with its typical fusion crust on the outside that formed during entry into the atmosphere. And when we cut it open, we can see the history of this meteorite. Here you can see the original part, which hasn't much been changed since its formation, and which will tell us all about the solar system. And all the black part, that's from a series of impacts that it has had between its formation 4.5 billion years ago and today, the different impacts it has had before hitting the atmosphere.
The rocky Chelyabinsk asteroid exploded in the atmosphere while others hit the ground. The world's largest display of meteorites here at the museum shows just how varied they can be, and exactly where they land makes a difference. A house-sized space rock can destroy a forest, create a tsunami, or even alter our atmosphere.
In the case of a shallow sea, and depends also on the type of sediments we have on the bottom, then a lot of greenhouse gases can be released by the vaporization of the material, and then it can really affect the climate on the long term.
So, what's being done to protect our planet from asteroids? Here at ESA in Germany, the space safety team is working on developing an early warning system, particularly for the more numerous smaller asteroids, like the one which came down in South Africa just a few weeks ago.
On 2nd of June, there was a big fireball in Africa. You can see here the asteroid of about 2 to 3 meters is entering the atmosphere, it's burning up, it's exploding. And that's what we want to observe, because if it's a bit bigger, maybe 5 meters, then the shockwave can create a significant damage on the surface. And that's what we wanted to inform the people about beforehand.
To be better prepared, ESA is building the Fly-Eye telescope, which will scan the sky for small and fast-moving objects. The agency is already monitoring 740 asteroids that carry a small risk of hitting Earth, and it finds new ones all the time.
We currently have a detection rate of something like 200 asteroids per month, and maybe 3, 4, 5 of them are objects which might hit the Earth. There's none which is really a serious threat, which we currently know of. There's plenty of things out there which we have not yet detected, which we are still searching for, but from what we know right now, there's nothing which we have to really worry about.
It's good to know your enemy. Both NASA and Japanese space agency JAXA have missions to visit asteroids this year. The Japanese spacecraft Hayabusa 2 will orbit its target asteroid this summer and drop a German lander called Mascot onto its surface.
We will find the landing site, and then October 3rd we will release Mascot, and then it will fall on the surface, and then we will get the information from the surface. And using this information, the second step after this will be that the Japanese spacecraft will also go to the surface, and they will sample the surface and bring the samples back to Earth.
The mission will help feed concepts on how to deviate a potentially threatening asteroid away from Earth.
It's not simple. You cannot destroy asteroids by atomic weapons or something like this, nuclear weapons. So you really have to know it. And the composition is most important in order to understand how you can push it away, how you can stop its rotation and get more radiation on one side and that push it away from Earth. So knowing the composition and knowing the physical properties will help a lot in order to investigate mitigation strategies.
So efforts are underway to prevent us from being the species that ends up in the museum. It's important to underline how a relatively small asteroid can have a catastrophic effect. Just look at this simulation of a 100-meter asteroid hitting Vienna and wiping the city off the map.
We just need to look at the moon, our next object in space, and see it's totally covered by impact craters. We don't see that so well on the Earth because the Earth has an active geological surface. But it happens all the time that we're being bombarded by objects from space, large ones and small ones. The larger ones are a little more rare. The small ones happen all the time. And this is something that happened in the past, and of course it will happen in the future again.
The consensus is that 90% of the large civilization-ending asteroids have been found and tracked. However, only a few % of the smaller ones have been identified. They're the risk that's being addressed now.